Hi, in this given lecture, we are going to talk about the PageRank algorithm. PageRank is an algorithm which was first used by Google Search to rank websites in their search engine results. PageRank is named after both the term web page and Larry Page, the co-founder. PageRank measures the importance of websites. It is a link analysis algorithm. To achieve page ranks, we have to repeat the same process until we reach a stable position whereby the page ranks calculations are stable. According to Google, PageRank works by counting the number and quality of links to a page to determine the rough estimate of how important a website is. The underlying assumption is that more important websites are likely to receive more links than other websites. PageRank can be defined as a vote, or we could refer to a support by other pages on how important a page is. A link counts as a vote of support. As of 2023, PageRank is not the only algorithm used by Google. In fact, as of September 2019, Google stopped to renew their PageRank patent. This is because Google has since started using another PageRank algorithm whereby their websites which are seeded. Nevertheless, the importance of the PageRank cannot be neglected. In the implementation and calculation of the PageRanks, we are going to look at the random suffer model. The random suffer model tries to describe the probability of a random user visiting a web page or website, and the assumption that this random user suffer is likely to follow links on the website from one website to another before he or she eventually stops. According to some researchers, PageRank algorithm outputs a probability distribution, meaning the PageRank results should be between 0 and 1. We are going to be using the simple formula for us to calculate the PageRank of a website or a page, where PRA or PageRank of A is the PageRank of page A, and where N is the total number of pages or nodes on our graph, and D is the damping factor, and PRTI is the PageRank of page TI, which link to page A, which we are trying to calculate, or we are looking at inbound links pointing to page A. And CTI is the number of outbound links of page TI, or edges pointing away from page TI. Researchers have agreed to set D, which is a damping factor, to a default of 0.85. The value of D should be between 0 and 1. The rank of a page is given by the rank of those pages which link to it. Page rank of each page depends on the page rank of those pages pointing to it. Pages have different weights depending on how they are deemed as important by other pages on the web page. We won't know the page rank of those pages until pages pointing to them have their page rank calculated. By default, each page is given a page rank of 1 divided by the number of pages or nodes on the graph to be considered. In so doing, by dividing by the number of pages, we make sure that the result of the distribution becomes a probability. When a page has no outbound links, its page rank cannot be distributed to others. It's referred to as a dead link or dangling ad. It becomes a sink, but random surfer will jump to another page. We have to keep iterating until ranks are stable. Let's take a look at the damping factor. When D is not given, by default it becomes 0.85. What implies is that when D is 0.85, it means that we have got an 85% that if a random user will follow a page on a linked website. Therefore, we then have a 15% probability that the random surfer will jump to a random page on the internet. In other words, to get the other side of the percentage, we then say 1 less D. Assuming we have a small universe of 3 websites, Web 1, Web 2, and Web 3 as represented with that graph, where Web 1 links to Web 2 and also links to Web 3, and Web 2 only links to or points to Web 3, and while this Web 3 also points to Web 1. And using our formula that we have there, we can then calculate the page ranks of Web 1 and Web 2 and Web 3 to see which one will be ranked higher according to the Google PageRank algorithm. So given now a small world where we have 3 websites as represented in the graph, we then want to calculate the page ranks of Web 1 to Web 3, and we are going to use our formula that we have already highlighted. And I have created another formula there so that it becomes clear. The better representation is the same as the one on top. However, we are faced with one challenge whereby when we want to calculate, initially we don't have the page ranks of all the nodes that we have in our graph or the pages of the web pages. We are not aware of the page rank of Web 1, Web 2, Web 3 as we start our calculations. So for the purpose of calculation, we are going to give all these nodes or pages the same page rank. However, what we are going to do is we would want to come up with a distribution value. So we would want all the page ranks to add up to 1. So what we're going to do is we're going to give them a value of 1 divided by n, right? Divided by n. In that case, this will give us 1 divided by, how many nodes do we have? 1, 2, and 3 divided by 3. right, divided by 3, which will give us a value of 1 divided by 3 is equals to that, right? So each of these values therefore have got the same weight as we begin our first iteration. So this takes us to our second iteration. So we were going to calculate the page rank of page 1 using the sum formula, and now let's substitute the values in that formula. So we are going to start with D, which is a default of 0.85, and our N represented by the number of nodes or pages, which is 3. We also substitute that value, and then we then look at this section where we want to do the summation of each page rank. Right. So what's happening with the formula is we would want to get the page rank of any node that is pointing to page 1. And therefore, if we're going to look at our graph there, we'll see that only page 3 is pointing to page 1. So we are going to substitute TI with web 3. Then we go on to say the count. Now we would want to say, whilst we are at web 3, count the number of arrows coming out or outbounds from 3 going out. And in our case, we have got 1. In an event that we have got more than 1 pointing out, what's happening with the PageRank algorithm is that it then says if any page's weight is then distributed equally to the outbounds, right? So in this scenario, we just say web 3, and then that's the only page that is pointing to web page 1, so we remove the remainder of the formula. We then take it down so that we compute the values. If you are going to do the calculations there, you will get a 0.15, and then our page rank 1 is a 0.3333. So when you are calculating, you will have to get the page rank from the previous iteration. So we are going to then go to web number 3 and get its value and bring it down there. And then we are saying how many outbound arrows are coming out from web number 3, and in this case it is 1. So we replace that with the 1. We take that value and then calculate. If you are going to do your math, you will see that you have got 0.15 divided by 3 gives you a 0.05. So we replace that with a 0.15, and this also will be replaced by 0.3333, like that. We take that answer down, and then we do our calculations where we put a 0.3333 multiplied by 0.85 gives us a value of 2.833. So we take this value and we give it down there, and we take it down. Now we have to add the 0.283 plus 0.05 gives us a 0.333 as an answer. So we take it down there. This now becomes our value for the page rank of web 1 in second iteration. We would want to do the same again to calculate the page rank of web number 2. So let's take out the formula from the top and bring it down there, change this to web 2, and then we can start substituting, right? And our D is 0.85 with N being the number of nodes, which is 3, and our D will be replaced by 0.85. Now let's go to our graph again and see we are at web 2, and we are saying how many web pages are pointing and which web pages are pointing to web number 2. In this scenario, we see that it's only web 1 which is pointing to web 2. So in that case, we replace TI with web 1, and TI be replaced with web 1. And in this case, it is the only one, so we remove the rest of the values there. We take it down, and then let's substitute those values. We see that whatever we are going to do here, coming from the top, we see the value gives us a 0.05. So let's replace that with a 0.05. And then the page rank of web 1, if we go to check it on the previous iteration, it will be 0.33. So we are going to take it from the previous iteration there and bring it down. And then we go to the count of web 1 outgoing. We go to our graph there, web 1, how many outbounds arrows that are coming out, going out from web 1. We see that we have got one pointing to web 2 and we've got another one pointing to web 3, which makes them 2. So we are going to replace that with a 2, right? So let's take that down and work the values. So if we are going to take that value, you will see that we have got 0.0333 divided by 2, giving us 0.165665. So we are going then to replace this value with that. Then let's see how that looks. The next thing is then we then want to multiply the result by 0.85, which is here, multiplied so that we get the value, and then this gives us a 0.14. We copy that. Okay, we copy that to our working environment. And once we have that value, then we can then say, let's add 0.05, 8.05, which gives us a 0.1965. So we take that and we bring it down there. This now becomes the value of the page rank of web number 2 in second iteration. So this takes us to calculation of web number 3, right? Web number 3, when we have that formula. So let's take it down. Let's substitute the values, D with a 0.85, and N with a 3, and our D with 0.85. And then while we are at web number 3, we then want to go and stand at web number 3 and check to see how many pages have got their arrows pointing to web 3. And as we can see, there's an inner bound arrow coming from web 1. We also have another arrow coming from web 2, which gives us 2. So we're going to replace TI with web 1. Replace TI with web 1, and then we also have web 2 pointing to web 3, so we are also going to then replace TN with web 2, replace TN with web 2, like that. So we then take down this so that we can do some replacement. Supporting 9. Coming from the previous calculations, this result will give us a 0.05, so we quickly replace that. And we want to get the page rank of web 1 while we are in second iteration. It then gives us a 0.33 to be the result of that. So we bring it down on web 1. And then we then want to see how many arrows are coming from web 1, and we see that we have got 1 and 2. So we replace that with a 2. The same for page rank number, web number 2. From iteration 1, we know that the value are equal, and it gives that. And then when we go to web number 2 to check outbound arrows, we can see that we count, we only have 1 which is pointing to web 3. So we are going to replace the count there with the 1. Then after that, we then do our maths. So we have already calculated 0.333 divided by 2 to give us a 0.165. We copy that, we replace it with here, and we already know that this one divided by 1 will give us a 0.333, like that. So let's continue with the calculation. Now we have got this value, we then want to add 0.3333 to that to give it 0.49995. So we are going to replace this with this answer, and we take it down. So this is the value that we have, which we need to multiply by 0.85, so that we get a 0.42. So we replace that with 0.42. Then from there, we also need to sum up those values by add a 0.05 to that value. We get a 0.47495, and we put it as it is without rounding that figure. So let's see how it looks after the second iteration. Summary of second iteration, where we have page rank of web 1 is equal to, we just copy that, bring it down, and then we want 2 and we want 3. So let's get the 3, is here, let's put it there. Let's go and get the value 2, put it there, and page rank of 3, and then of 1, and put it there. So Having started with an iteration where in iteration number 1 summary, all the pages were of equal importance with the same value. After the second iteration, we can see that web page number 3 has got more weight, more value, followed by web 1 and then last web number 2. But we still need to see if this is the results by going through another iteration. So we are going to do an iteration number 3, where we would want then to calculate all the page ranks again. So let's go and do the third iteration. So coming from web number 1, these all values will still remain the same. Let's just copy them down and we start from there. And let's just do the same for web number 2. Let's copy this one and bring it down like that. Let's also do the same for web number 3, and we also have to bring it down. So now we can now start our calculations, and we take this last value and then let's see how we then substitute, and we already know that this will result in 0.05. and what is the page rank of web number 3? We now in iteration 3, let's look in the previous iteration, which is iteration number 2, and we want the value for 3. So we take that value and we bring it down there. Right. Now that we have that value, we also know that if you are at page number 3, only one outbound arrow is coming out. So the denominator there is going to be changed to a 1, like that. Right. So this then gives us this value if we are going to do our replacement there. Our calculations divided by 1 gives us the same value. So let's take that value to our calculator there, paste it, and then multiply by 0.85. We get a 0.40. We copy that and we bring it down to replace this value. And then once we have that value, then we need to add a 0.05 to that value. We get a 0.445. We copy it and we then bring it to our working environment. Now let's proceed to do the calculation of web number 2 at third iteration. So we copy that and we bring it down. Right, and we already know that this value will result in 0.05. And now we are taking the page rank of web number 1. So let's go look at the web page rank number 1. We copy that. We bring it down to replace this value there, right? And then if we are going to look at web number 1, there are 2 outbound arrows, number 1 and number 2, pointing to web 2 and 3. So let's replace that value with a 2, so that we can then start our calculations. Right. And we take this value of page rank number 2 to our calculator, and then we divide it by 2 to get a 0.16. So we come and replace this value with that result. Then we multiply the result with the 0.85 so that we get a 0.146. That will be the product, and we now need to add 0.015, so add 0.05 to that. We get the 0.19. Copy that and we'll bring it to our working environment. We are now done with the web page, PageRank of web number 2. Let's go on then to calculate the web page, PageRank of 3, and we replace that formula. We already know the result of that to be 0.05. And then we go to PageRank of web 1. Let's go and get it from the top. Right. So we replace that with that, and according to our diagram, web page number 1 has got 2 outbound arrows, so let's replace that with the 2. And then we also do the same for web number 2. We take it from the previous iteration, and then we replace it on our formula there. And if we look at web number 2, it is with 1 outbound arrow, so we are going to put a 1 there, and then we can now start doing the math. Alright. What value do we get from there? Let's take our calculator and let's deal with the 1 there. Okay, so we do that and we divide by 2, we get a 0.1666. We then want to replace this with that value, and we also know that this will also result in us having the same value like that. So once we have that, we continue with our presentation. So what we want to do then is we want to add this to the result what we have on the calculator. So we just then say, okay, let's go ahead and get that, copy and then paste it there, and then do an addition, and we copy the next value, we clear that, we do a paste and save. We get a 0.358, so that we bring it down there. Once we have that value, we then can go ahead and multiply the result by 0.85 to get a 0.3 as our value. For this result, we get that. And then the last thing that we would want to do is then to add 0.05 to that, and we get a 0.35 is our answer to a PageRank of web 3. So let's come up with our summary. See how the page are ranked. Summary 3, summary automation number 3, PageRank web 1. Just do a quick one there, and then change that to 2, and change that to 3, and then let's get the value of the web 3.
Let's get the value of web 2. And lastly, the value of web 1. And let's see how they look like. After the third iteration, we then discover that web 1 is now highly ranked over web number 3. So pages have changed the ranks. So let's continue to the other iteration and see if the results become stable. So we then begin iteration number 4. So we'll do the same as we did on top there, because we already know that this formula is not going to change. What's going to change are the values. So we are going to take page 3, and then we are also going to take page 2, and then the last page is page 3. Right, so we have those values now. Let's now start to put some values in there in our fourth iteration. So we already know that the value of that is going to give us a 0.05. Let's just quickly do a substitution. And we need the value for web number 3, so we're going to take the value there, and we do our replacement. And we already know that web 3 has got one outbound arrow, so let's replace that with 1. Now we then do the calculation of that value there. Take that value, multiply it by 0.85, gives us a 0.3. So that gives us a 0.3, and then we need to add a 0.5 there. We then say plus 0.05, we add, we get this result. We take it and we bring it to a working environment. So that will be the page rank of web 1 in the fourth iteration. We then want to do web number 2. Let's get that value, put it down there. Substitute the value, we already know the calculations, and then we need web number 1. So let's go fetch web number 1, and we bring it down there. And according to our graph there, we have 2 arrows pointing out of web 1, so we divide by 2. We take that result, bring it down, and then we have our web 1. We copy it and bring it to our calculator, divide by 2, we get a 0.22. We copy that, so that we now replace this value like that. And once we have done that, we now need to multiply it by 0.85. So multiply by 0.85. 5 gives us 0.192. We copy that and we replace this value, and that's once we are there. The next thing we need to add 0.05 to that, so that we get a 0.242 is our value, and is our page rank for web number 2. Let's proceed to do the other page, which is page number 3. Let's take our formula from there and start our replacement, and we are already aware that this one will give us 0.05. Then we also want the page rank of web 1 and its count, which is what we have on top there. So let's go on and take that and then bring it down, and this gives us that, and we now know that we divided by 2, since this is the same formula from the top. And we now want the value of web number 2, so let's go to web number 2, its page rank. We bring it down there and we replace that, and we know that it has got only one page pointing to coming out of it. So we take that formula and let's now do the calculations. We have already calculated this value, but we are going to do it again. So we paste that value there, we divide it by 2, we get 0.226. We replace this value by that, and then we also have a 0.1. We copy that. We already know that it will give us the same result, so we paste it down there, and then we come down to the sum, and we want to add this, so let's do an add, and then we paste that and we get a 0.41851 being the result of that addition. And the next thing, we then want to multiply it by 0.85, and multiply by 0.85 gives us a 0.35. So we take that value to this place. So we then also want to get the result of that by then adding 0.05 to it. We get a 0. Let's copy that. We get a value of 0.40. Now we have reached the end of the iteration at this level, so let's come up with a summary. Iteration number 4, right? Iteration number 4, and let's go for PR of web 1 is equals to let's replace them with a 2 and a 3, and then let's get the value of web 3, value of web 2, and then lastly the value of web 1, And let's look at the results. After the fourth iteration, we see that web number 3 has regained its position as highly valued, then followed by web number 1, and then lastly number 3. So you could go ahead and try to do the fifth iteration and check to see if the results will be different. Once we have a stable position, we then stop the iteration and we consider the results. And in this case, web number 1 becomes the first highly ranked, and then web number 1 becomes the second one, with web number 2 being the last ranked in this scenario in our case. So this is how you calculate PageRank of websites using the random suffer model. This brings us to the end of today's lecture. But before we end, if you are new to this channel, please kindly click that subscribe button so that you won't miss the future updates and new uploads that we are going to put on this channel. I'm out.